Hi viewers, I'm Nadeem. Bismillahirrahmanirrahim. Welcome to the Farooq Academy. Today we will discuss chapter number 11, exercise 11B, book D3, further trigonometry. Question number 1. In question number 1, find the area of the following figures. That is in figure number A. You see here, first of all, you have to draw the figure. That is your 9, and this one is 8. And this angle is 72 degree. So we have to find the area. Since we have formula, that is area of triangle ABC is equal to half base into altitude into sine A angle. So putting the values, where is the base? That is base is 8. So after putting the values, you will get sine A is 72 degree, and after simplification you will get 34.2 centimeters square. So that is your result. Now coming to the B part, again, since area of triangle PQR is equal to half base into altitude into sine Q, that is half what is base. So first of all you have to draw the configuration, then we are able to see what is the value of Q, and so that is your 112, that is 112 degree, and that is your 9, and this one is 7. So putting the value, that is your base, that is your altitude. So after putting the values, you will get sine 112. So after simplification you will get 29.2 centimeters square. So that is your area of a triangle PQR. Now coming to the part number C. Once again you have to draw the triangle first, then you see that is your 57 degree and that is your 10, that is your 12, 62 degree, and the value is given to us. So since area of triangle LMN is equal to half base into altitude into sine M. So we don't have the value of M, so we have to find it first. How can we find? The sum of interior angle is 180. So angle M is equal to 180 degree minus the sum of these two. So minus 57, also minus 62. So you will get 57 and 62, 119. So the angle M is 61 degree. So you can put here, so now the value of base, altitude and sine 61 degree. So you will get by simplification, that is your result. Now coming to the D part. Area of, since we have to find the area of triangle STU, that is equal to half ST base, altitude and sine T, because you see the shape. that is 7.3, that is 6.5, that is UST, and the angle is this is given to us, that is 28, and the figure is given in your textbook, it is 105 degree. So that is equal to half into the value of ST is 6.5 and 7.3, and sine, we don't have the value of t because it is unknown to us. How can we find? As sine t, angle t is equal to 180 minus sum of this, so 105 and 28, you will get 133 degree, so that is approximately 47 degree. So put here 47 degree. So by simplification, you will get half 6.5, 7.3, and sine 47 give you 0.7314, and multiplication and division by 2, you will get 17.4 centimeters square. So that is your result. Now coming to the part number D. In part number D, we have been asked that we have to find so E part. Once again, we have given a diagram. You can see here. A, D, B, C, 117 degree, 5.8 and 5.3. So area of parallelogram, we have to find the area. Since area of parallelogram is equal to twice the area of triangle ABC, twice the area of triangle ABD, ABD. So that's why I have divided it. So it means twice the area of triangle ABD. So first I have to find the area. So putting the values, we know that half base into altitude, sine A. So this will be cancelled, so the B, base, altitude and sine A we need only. The value of B is 5.8, the value of A is 5.3, and sine 117 degree. So simplification, you will get 27.4 centimeters square. So that is the unit of area. Similarly, in F part, you can see once again you have been given the same type of figure, that is R, Q, 8.5, 78 degree. This side is equal to this side and this side is equal to this side because it is a parallelogram. Parallelogram having opposite sides are equal, but I don't think so that this is the angle is 78 degree sorry, so maybe we can say that it is the area of rhombus. So area of rhombus is equal to since, but the formula is same used for parallelogram and for rhombus is the same. So since area of rhombus, so is equal to base into altitude into sine p. So for rhombus we don't use half value because half value is often used in triangle. So putting the values, that is your 8.5, the value of altitude is also 8.5, and the that is the 8.5, and what is the value of this? It is a rhombus, so that's why having equal sides, so into sine p. What is the value of p? So p is 78, but we have to put that is sine 78. So after further simplification you will get 72.25, and the value of sine is 0.9781. So after multiplication you will get 70.7 centimeters square. So that is your result. So coming to the question number 2. In question number 2, in triangle ABC, A is 45, B is 15 centimeter, and C is 22 centimeter. Find the area of the triangle. Oh, okay. So for the area of triangle, everything is given to us, only we have to put the values. For example, since area of triangle ABC is equal to half base into altitude into sine A. So putting the values, the value of base is, that is the sine is 45 degree, and the value of b is given to you, that is 15, and the value of c is 22. The triangle ABC, okay, that may be C because the figure is not given to us. The value of C is 22. So find the area of the triangle by simplification. You will get the result. You use the calculator and to find. Similarly, in question number 3, PQR. Question number 3, the value of angle P is given to you, that is 72, Q is 152, R is 125 centimeter, and what is the area of the triangle? Once again, since we have a formula, that is area of triangle PQR, that is equal to half Q cross R sine P. So what is the value of Q? It is given to you, a very simple question, that is 152, and the value of R is given to you, that is 125. And sine P is given to you, that is sine P is 72 degree. So by simplification you will get the result. For example, I have a calculator, so we can simplify it for your convenience. That is sine 45, you know, that is equal to 0.707 multiplied by 22 multiplied by 15 divided by 2. You will get the result is area of triangle is 2. My calculator is giving these values, that is centimeter square. Similarly, first we find the value of sine 72, so it will give you values 0.95 multiplied by 125, then multiplied by 152 is equal to, so divided by 2, so we will get the area which is being calculated here, that is 9,035.036 centimeter square. So that is your result. So we can simplify it by using calculator, and the basically is how to use the formula, because this type of question we are using this formula because altitude and base are given to us and angle is also given to us. Only we have to put in the values and simplify. Now coming to the question number 4. In question number 4 we have been asked that we have to find in triangle ABC side A is 43 centimeter and B is 67 and C is equal to 32 centimeter. Calculate the area of the triangle. Okay. In question number 4, it means since area, how can we find? In first part we have to find the area. So area of triangle ABC is equal to half base into altitude, that is A into C into sine B. So putting the values 43, 32 and sine 67 degree, so the result is 633.3 centimeter square. How can we get the values of this? You can see the diagram by reading the given questions, that is D, C, B, A, that is your 67 degree, and this side and this side is 32 centimeter, and that is your 43 centimeters. So when we take this triangle ABC, triangle ABC, we can use this angle and the given sides, so you can calculate the area of a triangle. Now in B part, why I have drawn this line? Because we have been asked that we have to find the AD in second part of this question. So we have to find AD. So again by using the same formula, area of triangle ABC, since area of triangle ABC is equal to half A into AD and sine D. If we use this statement here is your D point. So the value of A is 43 because we use in front of, this is your small a and this is your small b, this is your small c. You know, we have familiar of giving names in previous lectures, that in front of A, the vertex A give you the side small a, the vertex B opposite gives you the small b. Often we represent like this. So we have to Now we are having values A, so putting the values, the value of A is 43, the value of AD we have to find, so write as it is because we have to calculate the value of AD. So sine D, the sine D is here, you see this box shows that it is 90 degree, so simplification you will get 21.5 AD because sine 90 is equal to 1, so therefore it will give you this value. So the area of triangle ABC is already in previous steps we have calculated in number 1, that is your the area we have already calculated, that is your 633.3. we have to use here the value of triangle ABC we should use here, so that is 633.3, so 633.3, so but you need the value of AD, so dividing the value of AD is 29.4 centimeters, so that is your result. Now coming to the question number 5. Question number 5. First of all, we have to read the statement. In question number 5, given that the area of the rhombus is 40 centimeters and that each side is of length 15 centimeter, calculate the angles of the rhombus. Now we have to calculate the angle of the rhombus. That is your rhombus, for example. We have to find that is 15 centimeter is given to us. Now area of rhombus, since area of rhombus is equal to AB into AD, because base into altitude into angle, that is sine A. Okay, already the area of rhombus we have here, it is given to us, that is equal to 40 centimeters square. Okay, putting the values use here, that is 40 and the value of AB is 15. Sine A we have to find, so sine A is equal to that is your 25, 40 divided by sine A, so the value of A is equal to that is 0.177 and that is equal to sine A. So the value of A is sine inverse 0.177, so sine inverse this one 10.2 degree. So we have calculated the angle A, but still we have to calculate other angles also. So how can we calculate? Because as it should be noted that angle A is equal to angle C, that is equal to 10.2, just we have calculated. Angle A is equal to angle C, this angle is equal to this one, because the opposite angles are congruent in rhombus, so it means, and maybe, and B is equal to D, and this angle is equal to this one, B is equal to D. So if we able to calculate the angle B, so it will be equal to D. If we calculate D, so it will be equal to B. So A and C both are similar angle, that is 10.2 degree. So just we have calculated here. Now B is equal to D. Also angle B is equal to angle D. Okay, but in sum of interior angle is equal to 360. So as since angle A, B, C, D is equal to 360 degree. So two angles we have already known that AB is equal to, so A and C is equal to both having the similar angles, so 20.4, it gives you 20.4, 10.2 plus 10.2 plus angle B and angle C, angle D remains there 360 degree. So both are equal, so we can say that 2 angle B is equal to 360 and minus 20.4, so you will get 339.6, that is your 2 angle B. And what is the value of B? You can see here, therefore angle B is equal to 339.6 divided by 2. So divided by 2 you will get 169.8. So therefore angle D is also equal to 169.8 because both are equal. So that is your result. Now coming to the question number 6. In question number 6, you can see the triangle ABC, that is in which AB is equal to 40 and in ABC triangle AB is equal to 40, BC is equal to 80, ABC is equal to 30, XY is an arc of a circle. Now question number 6, we have seen here that the given configuration is like this, and in A part we have to calculate the area of triangle ABC. So for the area of triangle ABC, we have been given that we have to find the area of triangle ABC. We have to find in which AB is given to us, that is 40 centimeters, BC is equal to 80 centimeters, and angle B is equal to 30 degree because here is your angle B, and the since area of triangle ABC is equal to half AB into BC into sine angle B. So putting the values, the value of AB is equal to 40, 80 and sine 30 degree. So simplification, you will get that is 20, 80 sine 30.5. So by simplification 800 centimeters square. So that is your A part. But in B part, we have been asked that we have to find the shaded area. So it means to find the shaded area, once again we have used the same formula, that is area of a triangle. So shaded area, if we see in configuration, so that is your shaded area. So first of all, we have calculated the full area of a triangle. Then we have to find the small area of a triangle, then we have to subtract, so we will get the green color shaded area. So you can see here that is your 30 degree. So in triangle BXY, so now we take the small triangle. In triangle BXY, the area of BXY, since area of triangle BXY is equal to half, then BX and BY and sine B, that is equal to 30. So after simplification you will get approximately, by using, because it's a small type of triangle having equal sides, so by simplification you will get 25 centimeters square. So that is the area of small triangle. The bigger triangle having area which is equal to 800, now we have to subtract, then we get the shaded area. So you can say area of shaded portion is equal to 800 minus 25, you will get 775 centimeters square. So here is your result. Now coming to the question number 7. In question number 7, we have been asked that the figure shows, first of all we have to draw the figure, that is the given figure. So that is your given figure. This one is equal to 60.5 degree, that is 197, and this angle is 30, and this side is 112, and so let me say that is your A, B, C, D. We have given the name, so that is your 202, and that is your 112. So this is the given figure. So we have to find the area of, calculate the area of the state. For example, this is your state. Question number 7. Here we have represented a quadrilateral ABCD, which is equal to the sum of two triangles. One triangle is this one, second triangle is this one. So in first triangle we say that, for example, I take triangle ACD, this one ACD, in which AD is equal to 112 meter, AC is equal to 202 meter, and the angle A is equal to 30 degree. So area of triangle ACD, which is equal to half AC AD sine A. So putting the values, sine 30 degree. So after simplification by using calculator you will get this one 5656 meters square. So that is your area. Now you have to take the triangle ABC. Now in triangle ABC, the area is equal to half AB AC and sine A. So putting the values, half into 197,202 and sine 60.5 degree, so it is given to us. So when you take this triangle, so you have a two triangles. First we have calculated the area, and in second triangle when we calculate the area, so it will give you 118.3 meters square. So the area is 17,318.3 meters square. So the full area of the state ABCD, we have to plus all this area. So we can say that if you have been asked that what is the area of this state, so suppose, so area of the state is state ABCD, because we have represented from this quadrilateral, so it is equal to 5656 plus 173 or 18.3. So you will get the total area, that is 22,974.3 meters square. So here is your result. Now coming to the question number 8. In question number 8, the figure AB is equal to 20, angle BAC is equal to 90, ACB is equal to 30, and AD is perpendicular to BC. Find BAD in B part, BD in C part, the area of the triangle ABC. First, we have to draw the triangle, that is your triangle, that is D, C, A, and then your 20 centimeters, and here is your 30 degree, and this angle, D angle, is 90. So it is a given configuration in your textbook, if you see the textbook carefully. So this is your 20 centimeter. So first we have to find angle BAD. So how can we calculate? So first of all, we take the triangle ADC is a right angle. ADC is a right triangle, for which if we see this, so it is clear that from the figure that ADC is equal to 90 degree, that is angle D, and angle C is equal to 30 degree, and similarly the how can we find the angle A? So 180, so angle A is represented in figure, that is CAD, 180 degree minus, because it is 90 plus 30, so we can find this one. So 180 minus 120 degree, so you will get 60 degree. So here is your 60, as the BAD and BAD and CAD, so these two angles is given you the value 90 degree. So it means if we say as angle BAD plus CAD is equal to 90 degree, but you need the angle of BAD, so 90 degree minus CAD, because we have to shift this towards this one, towards this side, so you will get 90 degree minus CAD. Just we have right here CAD is 60 degree, so you will get 30 degree. So because we have to find the BAD band, so that is your result. Now in B portion we have been asked that find BD. Okay, how to find BD? In B portion we have to find BD. Since sine BD is equal to BD and AB, that is perpendicular by hypotenuse. So we have the values, so putting the values, that is the value of BD we have to calculate. The value of AB is 20 in the figure, 20 centimeter, and the value of the AD is 30 degree. So by simplification you will get the value of BD. For example, if we simplify it here, so you will get the sine 30 is, you can see here, 0.5 is equal to BD divided by 20. So you need the value of BD, so 0.5 multiplied by 20, so you will get 10 centimeter. So you have calculated the value of BD. Now in third portion we have to find the value of AC. Now we have to find the value of AC. In C portion we have to find the value of AC. How to find? Since tan 30 is equal to AB divided by AC. So once again it is your 20, we have to find AC. Tan 30 is 0.577, and the value of AC is by using cross multiplication divided by 0.577. so the value of AC after using calculator, that is your centimeter result. So that is the result. Now in lastly we have been asked that the area, that is the area of the triangle ABC, because this AC is very much helpful in to find the area, because area for triangle ABC, area, for example, area of a triangle, area of triangle ABC is equal to half base into altitude and sine angle A. So putting the values, so the value of AB is 20, but we don't have the values of AC, just we have calculated, so we have to use here, that is 34.7. Sine A angle is 90. We are already well familiar to this fact that this is equal to 90 degree. So your result is, after simplification, you will get 347 centimeters square. So that is your required result. Now coming to the question number 9. In question number 9, In figure, ADC is equal to ACB is equal to 90 degree and EAD is equal to 51.1 degree, CAB is equal to 40.4 degree, AE 44.1 centimeter, AD 3.7 centimeter and AC 8.0 centimeter. Find ACD, and in B part AB and C part area of the AED. First of all, we have to draw the configuration because the figure is given to us in your textbook. Figure is as for example, you can see here, first of all this, then we have to draw this triangle, then this one, and then the figure is like this. That is your AB, C, D, E, and this one is 55.1 and 4.1 centimeter, and this side is 8.0 centimeter, and this one is 40 degree, 40.4 degree, and 3.7 centimeter. So this is the given data and given configuration. So we have to find first the angle ACD. First, in A part we have to find ACD angle. So since we have a formula, that is sine ACD is equal to AD and AC. So we are using trigonometrical ratios because we consider the triangle ACD. We say that in triangle ACD we have come to this conclusion. So putting the values, so after putting the values you will get that is 3.7 divided by 8, so you will get 0.4625, but you need the value of only angle ACD, not sine. So ACD is equal to sine inverse that is equal to 27.5 degree. So here is your first part. Now coming to the second part, in which we have been asked that we have to find the value of AB. Now you see how can we find the value of AB. We have to find the value of AB. Now we consider the triangle that is ABC. ABC. In triangle ABC, the value of AB can easily be calculated since we are using trigonometrical ratios, that is cos 40.4 degree is equal to base by hypotenuse, that is equal to this one. So putting the values, you will get cos is giving the values was 7615 by using calculator. So by using cross multiplication you can shift it. The value of AB is equal to 8.0 divided by 0.7615. So the value of AB is 10.5 centimeter. So that is your result. Now in C portion we have been asked the area of triangle AED. Area of triangle AED. Area of triangle AED. So how can you find the area of the triangle AED? So it is very much simple. because we have a formula. Since area of triangle AED is equal to half AD AE and sine 55.1 because it is given to us, so the value is 3.7, AE is 4.1 and sine 51.8202. So after simplification you will get 6.22 centimeters square. So here is your result. Now coming to the question number 10. In question number 10, if you read the statement, in the figure ABCD is a parallelogram and B is a line segment. If DE is equal to 2AD and the area of ABCD is 20 centimeters square, find the area of triangle ABE. So first of all we have to draw the configuration, which will be very much helpful to us to understand in a better way, because without configuration or diagram very much difficult to understand what is going on. So therefore in question number 10 you see we are going to draw the diagram. That is we have a diagram like this. So that is your A, B, C, D, and that will be extended up to E, and if we join this, because it is given to us in this diagram, you can see it is given to us. So what we have to do in this situation, if we read this statement once again, the author of the book asks us in this question, find the area of triangle ABE. So it means area of triangle ABE. So we have to find the area of triangle ABE. So ABE. So that is your triangle, this one. So area of triangle ABE, no problem, which is equal to half base into altitude and sine A. So that is your required formula. So putting the values, you will get in this case, that is the value of AB still unknown to us, so we have to write AB. The value of AE still we are unable to find, so how can we find the value of AE? So the value of AE, so for further simplification you can see here, if we say that AE is equal to what, as AE is equal to AD, this and plus this, plus DE. So it means AE is equal to AD and DE is equal to plus 2AD, because it is given to us. If we read this statement, it is given to us that DE is equal to 2AD. So that's why it is given. So that's why we have used this here. So you will get 3AD. So AE is equal to 3AD. That is and sine A. If we go further, so you will get 3 by 2 AB, because 3, this can be written as here 3 by 2 AD, and the value of AD is equal to that is your sin A. Also here you have to write, but the value of AD, if we see here the value of AD, so if this parallelogram is divided into two triangles, so you will get this triangle, and here you can see that what is the value of AD. So to find the value of AD, we have to find the area of BCD and area of ABD. So then we are able to say that what is the value of AD, because it is a complex question, we cannot find easily. So here I can solve for you to understand in a better way. What is the value of, for example, we say that area of BCD as area of triangle BCD, that is given to us, that is 20 centimeters square. And so area of ABD, area of triangle ABD, so that is also given, also not given to us, but we can divide this, we can find, that is if we have area of 20, so we divide into 2, divided by 2, so you will get 10 centimeters square. So the area of ABD is equal to 10 centimeters. So we can say that ABD area having this one. So this result is helpful if we say as area of triangle ABD is equal to half base into altitude. Here base is AB, altitude is AD, and into sine A. So putting the values, that is your AB, AD, and sine A. So we have write again in a same way, because the area of triangle is equal to 10. So we need the value of AD, so we have to find the value of AD. So leave AD here and shift all the terms there. So by using cross multiplication, it becomes 20 divided by AB and sine A. So this result or this deduction can be used here. So putting the values, that is for AD, that is specially for AD. So the value of AD is 20 by AB sine A. So sine A will be cancelled with this one, AB will be cancelled with this one, and you will get 3 by 2 into 20. So 10 to the 20, 3 into 10, you will get 30. So 30 centimeter square is your result. That is your required area of the triangle ABE. So we have completed question number 10. Now coming to the question number 11. Now in question number 11, the diagonals of the parallelogram are 15.6 centimeter and 17.2 centimeter. They intersect at an angle of 120 degree. Find the area of the parallelogram. Now we have to find the area of the parallelogram. But it should be noted that suppose we have to first draw the diagram, then it would be much easy for you in question number 11. That is diagonals. So this is the diagonals. These are the, that is 8.6 centimeter, and that angle is 60. Angle is also 60, and is 120 degree. It will be also 120 degree. So A, B, C, D. So that is your also, and this is 7.8 centimeter. So diagonals intersect each other at point O. So diagonals are always equal. So if it is 8.6, so it will be also 8.6. So if it is 7.8, so that will be also 7.8. So it means these are equal and these portions are equal in length. As vertical angles are equal, so diagonals are also equal. So AC and BD are the two diagonals. AC and BD are the two diagonals of the parallelogram. So diagonals bisect each other at these points and having angles 120. So the area of parallelogram, now coming to the exact point, that is area of parallelogram ABD. Area of parallelogram of A, B, C, D. So is equal to twice the area of triangle ABC, that is, and twice the angle area of triangle, that is BCD. So we say that ABD and BCD. So if we say that ABO, twice the area of, okay, to understand in a better way, okay, twice the, I have to write here area of twice ABO plus twice the area of this one BCO. So we have to put the values, that is twice the area, that is area of ABO, that is half 7.6, 8.6 sine 120 degree plus twice half 8.6, 7.8 and sine 60. So by simplification you will get 58.09, 58.09. So you will get 116.1 centimeter square. So here is your required result. Now coming to the question number 12. In question number 12, in a quadrilateral ABCD, AB is equal to 3.2 centimeter, BC is equal to 5.1 centimeter, and diagonals BD is equal to 7.5 centimeter, and CBD 34.4 degree. The area of the triangle ABD is 11.62 centimeter squares, and ABD is obtuse. Calculate the area of the triangle BCD. So area of the triangle BCD, in A part, area of triangle BCD. which is equal to half BC BD sine B. So putting the values, also we have all these values in exact calculations, you will get 10.8 centimeters square. Here is your result. Because if we see the configuration like this, that is 7.5, 5.1 centimeter, 3.2. So A, B, C, D. So and that angle is equal to 34. This angle is given to us, that is 34.4 degree. Okay, now coming to the B portion, we have to find the angle of EBD, size of obtuse angle. Okay, first of all we have to find the triangle ABD, then we have to find the obtuse one. First, area of triangle, since area of triangle ABD is equal to half AB BD sine B. So putting the values, that is 3.2, 7 point and sine B. So the area of triangle ABD is given to us, that is 11.62. So you need the value of sine B. So you can by calculation it will give you 12 and it will be divided here, so you will get the value of B. We need the value of B, but you see here from this calculation you will get 12 and 12 is divided here, so you will get the value of sine B, and this will give you 0.968, but you need the value of B only angle, so sine inverse 0.968. So what is the value of B? So you can see here, therefore angle B is equal to sine inverse, you will get 75.5 degree. So for the, actually we have calculated the angle B, but we need the size of obtuse. So for size of obtuse angle, that is your ABD, or only simply B. ABD means only B, but for further detail we write as, so it is equal to 180 minus 75.5 degree. So you will get 104.5 degree. So here is your result. So we have completed exercise 11B. I hope that this will be very much helpful to you to understand in a better way. So thanks a lot. Thank you for watching.